Welcome to my channel. In this video I'm going to show how to draw shear force and bending moment diagram for simply supported beam. So now consider a beam which is freely supported at both the ends A and B of length L. W load. Consider a beam AB of length L simply supported at both the ends A and B, carrying a point load at midpoint. So this will be L by 2 and this will be L by 2. So due to this load there are two reactions. Due to this load, reaction forces are developed at the ends A and B. So that reactions will be RA and RB. We have three equilibrium conditions. Summation of V is equal to 0, summation of H is equal to 0, summation of M is equal to 0. Summation of V is equal to 0. Sum of all the forces in the vertical direction must be equal to 0. Sum of all horizontal forces must be equal to 0. Sum of all the moments must be equal to 0. So we don't have any horizontal forces here. So summation of H is equal to 0. We have three vertical forces here. So V is equal to 0. Sum of all vertical forces RA plus RB minus W is equal to 0. RA plus RB is equal to W. Take it as equation number 1. Now take moment about A. Force into perpendicular distance. Take moment about this point. So RB, force into perpendicular distance L minus W into L by 2. Get RB is equal to W into L by 2 by L. RB is equal to W by 2. Now consider this equation. RA plus RB is equal to W. Substitute this RB value in this equation. RA is equal to W minus W by 2. So you will get RA is equal to W by 2. Now we got vertical forces W by 2 and W by 2. Now consider a section 1 at a distance x from B between C and P. Now see here, sign conventions. This is positive and this is negative. Right part of the section, the force which is acting to the right of the section is acting upwards, so negative. SFX is minus W by 2. Bending moment, due to this force there is a sagging moment, so we'll get positive. So plus W by 2 into X. At B, X is equal to 0. At C, X is equal to L by 2. So SFX is equal to minus W by 2. BMX is equal to plus W by 2 into X 0. So we'll get 0. Then here SFX is equal to minus W by 2. Bending moment is equal to plus W by 2 into L by 2. That is double L by 4. Now consider a section 2 from left side. So this will be at a distance x. You can either consider it from right side or you can consider it from left side. Now the force is acting to the left of the section. So RA is acting upwards. So we'll get positive plus W by 2. Bending moment will be, so due to this force there is a sagging moment. Due to this force there is a sagging moment. So we'll get positive W by 2 into X. At A, X is equal to 0. At C, X is equal to L by 2. SFX is equal to plus W by 2. Bending moment will be plus W by 2 into 0. So we'll get 0. SFX is equal to plus W by 2. Bending moment will be plus W by 2 into L by 2. WL by 4. Now we need to draw shear force and bending moment diagram. So we have to extend these lines. A, B and C. At B, shear force is minus W by 2. At C, shear force is minus W by 2. At C plus W by 2. At A plus W by 2. So you need to join these points. So this is negative and this is positive. You get constant here. You need to shade this portion. Now bending moment diagram. A, B and C. At B, bending moment is 0. At C, bending moment is plus WL by 4. At A, bending moment is 0. So you need to join these points. You'll get linear because the degree of x is 1. So linear. So you need to shade these portions. So you need to remember this value WL by 4. This is maximum bending moment. All the positive values of shear force and bending moment diagrams are plotted above the baseline, and all the negative values have to be plotted below the baseline. And one more point is the bending moment will be always 0 at two supports of a simply supported beam. From this shear force and bending moment diagram, it is clear that the bending moment is maximum at C, that is WL by 4, where the shear force will changes its sign. So this is shear force and bending moment diagram for a simply supported beam when a point load is applied.